Welcome back. We're going to continue our discussion on chemical bonding. And in the previous video, we learned about ionic bonding, okay? And always, whenever you talk about ionic bonding, you obviously talk about covalent bonding also. But covalent bond is not just covalent bond, but in a nutshell, covalent bond means mutual sharing, okay? Covalent bond itself means mutual sharing of electrons. Okay, so you know the actual definition. Okay. But we have to be much more specific, whether it's a polar covalent or non-polar covalent. And for that purpose, we're going to use what is known as, what is come to be very popular, is the Linus Pauling electronegativity table. You do not have to memorize this table, as it will be tagged to an exam, or it'll also be posted on Moodle, so it's not something you have to memorize. But like I said, you have to be very specific whether you're talking about polar covalent or non-polar covalent, because that's very, very important. Whether it's polar covalent or non-polar covalent, covalent means that the interaction is between two or more non-metals, which means you do not have a metal at all in the picture. So I'm gonna give you some compounds, because you do not have to create covalent compounds. I'll just give you compounds and show you how to use the table. All right. For instance, CS2. Let's say I give you a compound, and I ask you whether the bond is ionic, polar covalent, or non-polar covalent. Is carbon a metal? Well, right away, ionic bonding is out of question. They're both non-metals. So you go grab the values for both of these, carbon and sulfur. Carbon is 2.5 and sulfur is 2.6. Always put the higher value before the smaller value. Keep in mind, I am not multiplying the 2.6 by 2, because a sulfur is a sulfur, whether there's 2 of them or 10 of them, just one time, all right? So it's 0.1. Now, this is something you do have to remember that I won't provide to you on the test. 0, if the value difference is 0 to 0.5, it's non-polar covalent, okay? If the value is between 0.6 and 1.6, it's polar covalent. And if it's 1.7 and above, it's ionic. This is something you do have to remember. This is actually the value difference, that is this value right here. So it's 0.1, so this is non-polar covalent. Okay, what if I give you H2O, water? Well, oxygen is 3.5, hydrogen is 2.1. That is, what is that? Right about, say, 1.4, isn't it? Yep. And that's polar covalent. Well, that makes sense, right? Water is one of the most polar solvents in the world, okay? That's polar covalent. It better be polar, because, otherwise we'll have some problems. Let's take NaCl. We can also use the table to identify compounds that are ionic. Well, sodium is 0.9 and chlorine is 3.0. And that would be 2.1, which is greater than 1.7, so it's ionic. All right, so keep in mind, if the metal is not alkali or alkaline earth metal, right away it has to be polar or non-polar, depending on the value. So this is very important. And then that's all I had to say about polar covalent and non-polar covalent, without using up any more of your time. And we're going to pursue into naming compounds, which would take a chunk of the next few videos. All right, stay tuned.